Okay, hi everybody, welcome to this afternoon session. My name's Alastair Porter. I am both the technical chair, the session chair of this session, and I'm going to start presentation first. So we'll swap around partway through and then we'll follow up with the participant presentations. So, as I said, my name's Alastair Porter. I'm from Pompeu Fabra University in Barcelona, along with Dmitry Bogdanov and Hendrik Schreiber and Julián Urbano from TU Delft. We've been working on the AcousticBrainz Genre Task, which was our first time presenting, first time promoting this task at MediaEval this year, and we believe we had a quite successful task with 5 participants. So I want to just start with a little bit of a background in music information retrieval and genre recognition in particular, which is what we're doing in this task. So genre recognition is a very popular task in music information retrieval. In general, the task is to play somebody or play a computer a piece of music, and just based on the audio content alone, identify what the genre may be. So whether that's rock or jazz or pop or classical or modern or combination of any of those above. And that's what we're trying to do. Previously, in most tasks, most challenges that are doing this task, we only use a small number of genres, and these genres are often very, very broad. So you might say something like rock, in which case you're wanting to encompass everything from rock and roll in the 50s all the way up to modern alternative, or jazz, which many people know spread a long time period with lots of very different substyles. Classical, for example, where many music practitioners know that classical is not really a term, and perhaps we should more specifically say that we're talking about Baroque or Romantic or 20th century. So most studies work on this broad genres and don't think about these more specific genres that we may want to know as sort of more interesting sub-identification, subfields in our recognition. And also the studies don't really consider the subjective nature of genre. What may be rock to you may be pop to me, or alternative may be indie, or who knows, classical jazz may be cool jazz, maybe bebop, maybe something. And so there's a big problem with the nature of these labels. What do we mean when we talk about the genre of a piece? Additionally, it's quite often can be the case that a piece of song, a piece of music doesn't have one genre. It has multiple genres. It may be a combination of jazz and rock, or it may be a combination of pop and heavy metal. And so, finally, many of these tasks deal with very small data sets. We're thinking maybe 10 different classes with 100 examples in each. And so, we're trying to say here possibly that we're going to give you 1,000 songs, and based on those 1,000 songs, we want you to identify any type of music that's ever been created, which is not necessarily a reasonable task. So how are we doing this? Well, we're doing this with we're doing this task with AcousticBrainz, which is a project that has been built in collaboration with the MediaEval Foundation, which runs the MusicBrainz project, and Pompeu Fabra University. So we have a collection of 5.6 million audio files submitted by the public, by volunteers, and they run a piece of software called Essentia, which is a music feature extraction software, which we have developed at Pompeu Fabra University. We gather about 3,000 distinct music features, representing a lot of statistical information about spectral scope, spectral shape, rhythm and tonality of the music. So we've collected all of this data, we've collected these 5.6 million recordings. What can we do with it? Well, we decided that we would introduce the AcousticBrainz MediaEval task, where the goal is to predict the genre and subgenre of an unknown music recording given these pre-computed music features. And so this task is novel for a number of reasons. The biggest is that we're working instead of one ground truth that represents and says what genre each of the songs in the dataset is. We're working with 4 distinct, separate ground truths, and we'll discuss them a little bit further next. we're working with hundreds of specific subgenres. So instead of this broad task where we're only asking for identification into one of 10 classes, we're talking about hundreds of classes that a particular song could be classified into. We have a multi-label genre classification problem, so we're accepting of the fact that different people may classify a song as being in a different genre, in two separate genres, or that a song may actually correctly fit within two separate genres. And we have a very large data set. The data set that we collected has about 2 million recordings, which is a relatively large subset of what we have already collected in AcousticBrainz. So we collected genre information from 4 places. 2 sources we scraped from internet websites, Discogs and AllMusic. What's interesting about these 2 sites is they have explicit genre hierarchies. Here's an example of the genre hierarchy used in AllMusic just for blues. So a number of subgenres of blues and a number of styles within those subgenres. AllMusic and Discogs annotate at an album level, so they specify that a particular album is of a particular genre, and have this predefined taxonomy. And so for recordings, for songs in AcousticBrainz, we found the album of that song, we looked up the genre of the album on Discogs and AllMusic. Our other 2 sources of information, we have information from the Tagtron dataset based on btunes, and also information from Last.fm, which is a public community-driven website of music listening history, but also has a rich tag taxonomy. So from Tagtron, it's a desktop application for organizing music, and it encourages users when they organize their music to submit information about that music back to the central database. And so from there we were able to gather genre information about songs. From Last.fm, there's a large number of taxonomy tags. Many of these tags represent things like genres, so you find lots of tags like rock or pop, but also a number of tags such as I like this song or favorite song ever, songs that I like to listen to in the shower. So a little bit messy, a little bit noisy, this dataset, but we've cleaned it up for this task. So for these 2 sources, we performed an automatic inference of genre and subgenre relations in order to get this 2-level hierarchy that we're working with, that we have in Discogs and AllMusic. So first of all, we did some normalization of the tags to make sure that we didn't have duplicate tags that meant the same thing, so we cleaned up some things, and we did a little bit of blacklisting to get rid of some labels, some tags that we knew we didn't really want in our dataset. We did a cooccurrence analysis to determine the hierarchical relationship of these genres and subgenres. So as an example, suppose we had a tag called alternative. And so we looked at all of the other tags that co-occurred with this tag alternative in all of the items that we had in our dataset. And so as an example here, imagine that the tag rock co-occurs with the tag alternative at a particular probability. We can look at the opposite. We can look at the number of times that the tag alternative co-occurs with the tag rock, and we see that this co-occurrence is not symmetrical. And based on this asymmetry, we can then derive the fact that it seems that alternative is a subtag, a subgenre of rock. And based on this process, we built up this tree of genre annotations. So I've got a bit of time, little bit of time just to give a suggestion, give an example of the kind of thing that we're trying to do with this task. So we want YouTube to load. Here we go. Wait for the ad to play. So take a listen to this, and afterwards I'll ask what you think the genre should be. All right. Any suggestions?
Electronic.
Electro? Dub?
serving beer. I mean, this is.
Well, so let's look at some sources. This is all music. This is the album that we were looking at. We can see in the bottom left, genre electronic. Well done. It has some styles: ambient dub, world fusion. So this is an album with a lot of African influences. The musician travelled to Africa and recorded with some local artists. So that's great. Electronic dub sounds good. But let's take a look at something else. Discogs says that it's reggae. Why? Well, because Discogs says that dub is a subgenre of reggae. So someone has said that it's dub, which is fine. But because of the position in the hierarchy, it also has to be classified as reggae. Or let's look at tags on Last.fm. We do have dub, but certainly not the most popular tag, which is world, which is very descriptive, as I'm sure you can imagine. So classification tasks typically rely on this agreed answer for ground truth, and we don't have it. And so this is one of the things that we were trying to encourage participants to consider in this task, is when you have annotations from various sources for the same item, what do you do when to see if there is agreement or disagreement? So we had two subtasks. The first, we built a single. We asked for participants to build for each of our individual datasets a single model, which we then evaluated on each of the datasets independently. And the second subtask, we asked them to build a single model utilizing all of the data from all of the separate data sources that we provided, and then we evaluated that again individually on each of the data sets. So we built 4 development and 4 testing data sets, and so we ended up with about, as I said, about 2 million recordings, which you can see in the information table, with the largest of those data sets being the All Music data set with about 1.3 million recordings. Dmitry, would you like to finish with the results?
What's time left?
Yeah, 5 minutes.
Okay, so thanks. We received we received submissions from 5 teams, so I think for the first year, we think it's a good start. Teams started working a bit late, I think, but that's like also we are learning how to organize the task, and they were able to do the submissions for each subtask, up to 5 submissions, and in total this means that they have 5 submissions, 2 tasks, and they are evaluated on 4 data sets. In total this is 40 runs, let's call them evaluation runs, per team. And overall we got 115 runs from our participants. So we put 2 baselines. One is just a random prediction of genre and subgenres following the distribution that we saw in the development datasets. And the second baseline is, we call it popularity baseline. It always predicts the most popular genre found in each data set, and it doesn't work with subgenres. Just a bit about the methodologies that participants tried to summarize overall. Everybody did more or less manual feature preselection. Some of teams knew about our descriptors and they had some expert knowledge that helped them in selecting the descriptors to use. They used classifiers. One team proposed a hierarchical classification, so first classify a genre with SVMs and then, knowing the genre, classify each subgenre using extra trees. Other approaches work with different variations of neural networks, deep learning, and also there was an attempt to use random forest classifiers. The main, let's say, the idea of combining different datasets together into one system, task 2. So here there were 2 ideas how you can, let's say, match genres in one dataset into genres in another dataset. One idea is do string matching, so you just have genre labels and you can then match those. and then you have predictions by different classifier strength on each data set, and then you can have a voting strategy to understand the winning labels. And another approach was to have a translation matrix where any subgenre of any data set could be, or genre can be translated to genres and subgenres of any other data set based on the analysis of co-occurrence of the annotations by genres and subgenres in the intersection of all 4 data sets. These were the main ideas that were tried. We used precision recall and F-score. We considered averaging per recurring and averaging per label. When averaging per recurring, we computed these metrics considering all labels, so this will be including genres and subgenres together, like they were kind of equal in importance. And also we computed these metrics only considering genres, so we wanted to know the performance. What if our task is more simple? Let's say, what if we only had to predict genre? And also only performance when considering subgenres. Finally, the results that we observed, they were consistent across all 4 data sets, which was nice, and in all data sets, which are columns, we had a clear winning team, let's say, that in all modifications of their approach, they were doing really well. So this is the JKU team that will explain their approach in the next presentation right after me, followed by the team DBIS, which also performed better than our baselines. Our baselines were rather simple, and we were we found that other approaches could not compete. Let's say they could not surpass these baselines. So this means that either their approaches should be refined and improved, and also it can mean that they were limited in the how they process the data, if they had a knowledge about the the expertise in music features for preselection, etc. Also, there could be an issue of overfitting the models. So we have consistent results, and I think I want to highlight also that there was a consistent pattern that, on genre, if we only consider genres, the task is much easier, so the results are better. You have here precision and recall, and the proposed approaches, they are towards up to the right, compared to the genre. So we have here subgenre, and here on the left we have genre for as an example. So this means that this task, subgenre classification, that was never considered before, it's really more difficult. The task makes sense for us. There is space to improve the task. In particular, one team exploited the idea first to identify the genre and then try to refine, then already knowing that genre, what is the subgenre. So taking into account the hierarchies, there is some work to be done. In fact, all our data sets are heavily unbalanced. This explains the difference in per label and per track results, in the values of F-score. I think if I would select one particular dataset, that was kind of the most difficult was all music, because they contain 700 subgenres, I guess. That's the reason. We unfortunately haven't seen significant improvement from combining genre sources together. So there was a small improvement, like 2%, but we were waiting for something much more significant. So the question of how to combine different ground truths together, different annotations together, it remains open for us. We want to work in that direction. So finally, just to say, AcousticBrainz is an ongoing experiment in the collaborative, it's a collaborative work, and this is our starting point. Our idea is to identify promising systems in the challenge and try to integrate them into our infrastructure and then have more feedback from the community on evaluating these models, already like real people listening and complaining to us. So this is nice to have a community, I guess, so we can do this. Yeah, so I think I already covered the rest, so let's now see the yeah, just one note that everything is open. The methodology for evaluation, everything is completely open. It's on GitHub. Data is open, so we are very into transparency. And we also publish now the validation datasets used in this iteration. If you remember, we kept 15% for later, so this will be the next year. Yeah, thank you. So let's now see our participants. Yeah.